Hi everybody, today we are going to be looking at Pearson Text section 8.6 and talking about the law of cosines. We're going to jump into it real quick, show you what it means, let you see some examples, and then basically let you take it on, alright? So here we go, the law of cosines. Like the law of sines, like what we learned last unit, law of cosines is going to work for any triangle. It does not have to be a right triangle. Alright. Once again, we're going to use the same designation for the angles and the sides like we did on the law of sines. So, capital A, capital B, capital C will be used to designate our angles, while little a, change colors, little a, little b, and little c will be used to designate the sides opposite those corresponding angles, okay? So, big A is opposite little a, angle big B is opposite side little b, and the angle called big C is opposite the side little c. Alright, so we're going to use the same kind of picture, same kind of designation. Okay, unlike the last unit though, I'm not going to use up time this time proving it. I'd be happy to show you if you're interested, but let's do that on time other than here. So let's get right to the law of cosines. Here it is. For any triangle, not necessarily right, for any triangle, okay, where the lengths are laid out the way we had it, here's what we find out. Any side, okay, I just happen to pick A, any side squared is equal to the sum of the other two sides squared minus 2 times the lengths of the other two sides times the cosine of that angle. So once again, it's the pattern that's important here. We have A squared on one side of the equal sign, and it's a cosine of A that goes in the parentheses on the other side, while we have all B's and C's over here. Alright? So, what it means, okay, so for any triangle, the law of cosines look like this. What it means for us is that it lets us find angles and side lengths for triangles that we couldn't solve using the law of sines. Remember, on the law of sines, we had to have an angle and a side opposite from it. Well, the law of cosines allows us to get by without it. We can have, if we have three pieces of information, we can now solve any triangle using the law of cosines. If we know, for example, two sides, like let's just say C and B, and the angle between them, right? So we don't have a situation where we know any angle opposite. I know angle A, but I don't know little a. I know side C, but I don't know angle C. I know side B, so I can't use the law of sines here. Okay, we can also use the law of cosines if we know all three sides and no angles. All right, so three pieces of information, and it frees us from that constraint that we had in the law of sines where we needed an angle with the side opposite from it. So this does any other triangle that we couldn't do otherwise. Okay, now, you notice I kind of hemmed a little bit when I said we have a squared equals b squared. So anyway, when I presented this thing, a squared equals b squared plus c squared minus 2bc times the cosine of a, know that it applies anywhere on the triangle, okay? It doesn't just have to be a squared and cosine of angle a in the parentheses, okay, with the other two sides there. All right. We could also think about it as b squared equals a squared plus c squared. Again, the two sides that are not included, minus 2ac, and the cosine of b. Or c squared, side c squared, a squared plus b squared, the other two sides, minus 2ab, and the cosine of c. Okay, so there are the three patterns using the letters a, b, and c. And again, we can apply it to any of the three side angle combinations as long as we apply it right. Okay, now of course we're going to end up with triangles that are called PRQ, and the important thing is the pattern. So once you get used to seeing it, you will remember the pattern is what's important, that any side squared is equal to the sum of the squares of the two other sides minus 2 times the two other sides times the sine of that angle across from it. All right, so I used Q that time, but I wrote down P this time, so just pay attention to the fact that it's the pattern that's important, okay? And of course, you can always, if we need to, go back to any of these three or whatever makes the most sense to you. But let's show you how to use them. Okay, so we're going to start with a triangle ABC, and we're going to give you an angle B and a length of AB and a length of BC and ask you to find the third side. So as we are wont to do, you can pause, you can try going back and using the law of cosines formulas. Please do that if you want a challenge. If you don't, I'm going to reveal the answers here coming shortly. Pause if you want to work on it on your own. Otherwise, here goes. Okay. Once again, we are going to draw a picture. Not necessarily accurate. I just picked any triangle and labeled it with A, B, and C. Okay. And across from it, I know that this is little a, this is little c, this is little b. Okay. But instead of doing all that, I just instead chose to put in the information that they gave us. Okay, so I know that measure of angle B is 104. Measure of angle B is 104. Side AB is 48. Check. Side BC is 29. Check. All right, so there's a picture of our triangle. Now, because I am looking for side AC, which we have labeled as being the little b here, okay, I'm going to use that second form, this form of the law of cosines, just because it's convenient for the way our program is laid out here, okay? So I wrote that second form right here, and you can follow along. So little b squared, that's my unknown, equals a squared, 29, plus c squared, 48, minus 2 times 29 times 48, 2 times A times C times the cosine of B. And then we just follow our math, guys. Okay, so we're going to square 29, check, square 48, check, multiply all of this stuff together, check, and find the cosine of 104. Then we're going to multiply these guys together. That's what gives me what's in the parentheses here, okay? So that's all I changed going from this step to this step. Then I'm going to do the math here. Remember, minusing or subtracting a negative turns into a positive. So I'm going to add all three of these terms, and I get 3,818.51. When I take the square root to eliminate the exponent, we find out that B equals 68.1. All right, that's how it works. All right, now that we know B, however, 61.8, did I say that right last time? I may not have. B was 61.8. Okay, so when we did the math, that's what we find. Now that we're here, okay, we can find the rest of the triangle. Actually, might be a little easier by using the law of sines, because now we have an angle with the side opposite from it. We know that. We can use the law of sines. Sine of 104 is to 61.8, as the sine of A is to 29, and as the sine of C is to 48. So we can solve for the two remaining angles using the law of sines. All right, let's try another one. Okay, that's it. Yeah. All right, this time I'm going to cross you up. We're going to use a triangle, but we're going to call it KLM. All right, where we have side KL, side LM, and side KM. So this is another one of those situations where the last time we had two sides and the angle between them. This time, here's how we're going to solve a triangle, knowing three side lengths. Okay, the other application of the law of sines. Cosines, law of cosines. Pause if you want to try it on your own. Answer coming right now. Once again, draw your triangle, label it. Okay, so here's what we got. We are trying to find the length of the measure of angle M. All right, so that's our unknown right there. So here's how we're going to do it. We are going to use the law of cosines, only this time I put it in terms of the pattern that we're looking at. Sometimes, if it's easier for you to just call them A, B, I mean, we can do this, right? I mean, it's legal to go ahead and think about it in terms of the A, B's, and C's if that makes us feel better, okay? And then we can use the forms that we have listed here, whichever one makes us happy, okay? But like I say, sometimes I think it's just easier to remember that we got a pattern that we can follow, and it would look like this. Now, since I'm looking for angle M, I want to use a form that has the cosine of the angle here, right? That means I put its opposite side on the other side of the equal sign and use the K's and L's for all of these parts in here, okay? See how that works? So, therefore, and plug in the values. Little m is 10.2. Check. The two sides that go on the other side of the equal sign, 16.8, 19.3, 16.8, 19.3. And my unknown here is the cosine of m. So when we do our math, we square that, square that, square that, multiply all these guys together to get that. Okay, next step, I added these two together to get this. Okay, so I'm pretty much just simplifying stuff as best I can. Okay, now here's where it gets a little spotty. Everybody wants to do this subtraction step first, but don't do it. That's a bad mistake, okay? Because we got to remember, this is all multiplied together, so I can't add those two together. What I need to do first is subtract that 654.73 from both sides. All right? So remember, these go together. Don't take them apart. So from here, we subtract 654.73 from both sides, and we end up with this. And the rest of it is still carried on down there just the way it's supposed to be. Now, since this is multiplied, we divide both sides by 648.48. Okay, so when I divide this by 645.48, I get that value there, and when I divide this by 648, of course, that turns to 1, and we're left with just the cosine of m on the right-hand side of the equal sign. Now, of course, to find an angle, remember we use the inverse cosine on both sides, and we come out finding that the inverse cosine of 0.8492 is 31.9, therefore the measure of angle m is 31.9. Okay, so that's how it works to help us find the dimensions of a triangle. Let me mark this down. So now that we know 31.9 is the measure of m, okay, once again we can go and get the other angles, that one and that one, once again using the law of sines. All right, the sine of this 31.9 over 10.2 is equal to the sine of k over 16.8 is equal to the sine of L over 19.3. All right, so when we use the law of cosines, we usually only have to do it once, and then we use the law of sines to tidy up with the rest of the work we have to do. But that's how it works in the two situations. Over here with two sides and an angle, this example shows us how it's done with three sides where we find the angle, and the next example is going to show us how it works into a word problem. So pause, answer coming now. All right, so we're going to draw our picture of our triangle. Okay, you and a friend are starting at camp and hiking 1.4 miles west. Two other friends are hiking 11 degrees east of south for 1.9 miles. Now the tricky part here is that this is what 11 degrees east of south means. Okay, it means I would look at what's pure south and go 11 degrees over that way. So this is an 11-degree angle. Let me clear those off for you. Okay, so that's the way our triangle looks. Now, since east and south are perpendicular, I know that this is 90 degrees and our total angle here at this side is 101, right? 90 plus 11. Let's call this opposite side D, just for something to call it, and recognize our pattern again now. Since I know this angle, I can solve for side D using D squared over here and its opposite angle over here with whatever's left in those other spots in the formula. Okay, so you can follow along again with how that works. All right, D squared equals the one side, the other side squared, and the third side squared, minus 2 times those two sides, that one and that one, times the cosine of 101, or the cosine of the angle opposite the side we're looking for. Okay, once again, simplify 14 squared, 19 squared, simplify that to get 5 minus 5.32. Next, we multiply these two parts together to get negative 1.015. Then we add, we take the square root, and we find that D is 2.57 miles. And we'll have plenty of chances to work on this. So I hope it makes sense. Write a summary, and I will see you later.